Alright, we're going to continue on with patterns today. We're going to look at some more difficult patterns. So it's going to start with the same sort of patterns that we did next time, and then we're going to get to some more difficult ones where we're asking for the 50th number or the 100th number or something like that. It says, this is like we did last day, determine the next three numbers in the pattern. So 2, 5, 8, 11, we want to know what are the next three numbers in that pattern. And I'm betting that many of you have already got the answer for what the next 1, 2, 3 numbers are. What did you do to figure it out? You notice that this goes up by 3 and up by 3 and up by 3. Hey, if it continues always going up by 3, we have a pattern. So we're going to go 11 plus 3 and we get 14 for our next number. 14 plus 3 and we get 17 for our next number. 17 plus 3 and we get 20 for our next number. So there's our three answers right there, 14, 17, and 20. Did that sort of stuff last day. But now we have something different. Find the 50th number. And you know what I don't want to do? I really do not want to do this 50 times. We're only up to 3, 4, 5. The 7th number, do you really want to add 3 on 43 more times? No, you don't. So let's come up with a strategy for how to do this. And this is the key to today's activity or today's lesson. We want to figure out how to come up with a formula that will represent this pattern. So here is the key. What you do is just like we did before, you take a look at what's the difference? What's the amount that's changing by every time? And it is changing by 3 every time, right? Up 3, plus 3, plus 3, plus 3, plus 3. Okay, so what that means is you're repeatedly adding 3. Do you know what it means? Another word for repeatedly adding something? Repeatedly adding is the same as multiplying. Like when you go 5 times 2, that's the same as saying, let's add 5 2 times. So 5 plus 5. Or if you think of it the other way around, it's the same as, let's add 2 5 times. 2 plus 2 plus 2 plus 2 plus 2. What's this equal? 10. What's this equal? 10. 2, 4, 6, 8, 10. They all equal the same thing. Repeated addition is the same as multiplication. All that to say, don't get confused by that if that upsets you there. All that to say, when you find this difference, that means part of your formula is going to be 3 times something. If it went up by 4, it would be 4 times something. Okay? If it went up by 10, it would be 10 times something. So what we're going to do is we're going to go 3 times n. Let's put n, where n is the term number. Do you know what I mean by the term number? This is like the first number. We have this list of numbers, right? And in this number here, this 2, the n is equal to 1. It's the first number, so n is 1. This number here, the 5, n is 2. It's the second number. 8, n is 3. n is 4 in this one. N is 5 in this one, n is 6 in this one, and n is 7 in that way. In that one, sorry. So that's going to be part of our formula. It's going to be 3n. Okay, now we got to figure out, let's see if it works. If we take this first term, right, the first term is 2. Let me just clean this up a bit here. Let's get rid of this. So we're interested in this one right there. If we go 3 times n, which is 1 for that one, if we go 3 times 1, do we get this answer here too? No, we don't. 3 times 1 is only 3. What do I still have to do to get to 2? I need to take away 1. So here's a possible formula. Now, do I know for sure it works? I don't. What could I do? Try it on some of these other ones. So let's try it on this one. Let's see if we could get this term by doing it. This is the second term. So if we put 2, right, if we put this 2 right here, if we put 2 into the n, you'd have 3 times 2, which is 6. Take away 1 is 5. Hey, it worked. Let's make sure a few more of them work. What if we did this one? This is the third term. So if we put 3 in there, 3 times 3 is 9. Take away 1 is 8. It worked. Let's skip all the way up to this one. This is the 7th term. 3 times 7 is 21. Take away 1 is 20. It worked again. We did it. We found a formula for how we can now get any term. So in your book, they often make this formula equal to t, where t is the term, the value of the term, right? These are all your t values, the value of the term, and these are all the n values. First term, second term, third term. Okay? But don't worry so much about that. Just worry about this is a formula that we can now use. So we want to know the 50th term. Where are we going to put that 50? Right here. So what you'll do is t equals 3 times 50, take away 1. Well, 3 times 50 is 150, take away 1. This term is 149. We have now found that the 50th term in this pattern, if you were to go out 50 terms, that 50th term will be 149. Okay? A lot of the questions are just really similar to what we just did. So let's do one or two more, or maybe three, and we'll get this. So we want to find the 100th term. Oh boy, I really want to find a formula if I'm going to find the 100th term. So let's take a look at the difference. What do you notice here? You notice 3, right? And what do you notice here? 3 as well. But be careful. Don't just put 3, because it's not going up by 3, it's going down by 3. It's -3, it's take away 3, it's adding -3 if you want, whatever you want, but this is going -3, -3, -3. So what would the next term be? Well, you take away another 3 and you'd be at -8. You take another 3, you get -11. But I don't want to do this 100 times. So let's come up with our formula. Remember what we did back here? Once we found that it went up by 3 and up by 3 and up by 3, we multiplied 3 times n. Guess what you're going to do when it goes -3, -3, -3? You're going to multiply by -3. So you have -3n, or -3 times n. Like before, we'll say that t is equal to this. And now you just have to see, did this work? Like sometimes you'll luck out and that'll be the whole formula. But often it won't. Now remember, before I work through the formula, remember this is where n equals 1. This is our first term, so n equals 1. This is where n equals 2, second term. This is n equals 3, n equals 4, n equals 5, n equals 6, and n equals 7. So let's see if it works. I usually start with the n equals 1, but you don't have to. You could try whichever ones you want. But I'm going to try this one, number 1. So if I go -3 times 1, because it's the first term, right? -3 times 1, do I get 7? No, I certainly don't. -3 times 1 is -3, and I want to figure out what do I have to do still to get it all the way up to 7. I'm at -3, think your number line, here's 0, here's -3, you got to get all the way up, 3, 4, 5, 6, 7, you got to get all the way up here to 7. What are you going to do? Once you get to -3, you have to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I know a lot of people didn't need a number line for that, but I just want to be clear that what you still need to do is add 10. So this is a possible formula. I'm not saying it works because I should check it out by doing a couple more of these, but this is possibly what's going to be the formula. So let's try this one right here. So this is the second term. We would plug 2 right in here and see what happens. -3 times 2 is -6, and if I add on my 10, -6 plus 10 is 4. Yes, got it. Let's skip ahead a bit. Let's go all the way up to 5 here. If I put 5 in here again, I get -3 times 5, which is -15, and then I'm going to add the 10. -15 plus 5, sorry, -15 plus 10 is -5. Yes, yes indeed, we got it again. Try one more. I know it's redundant. It obviously works, but let's just try one more. If I put 7, because this is the 7th term here, if I put 7 in here, -3 times 7 is -21, plus 10 is -11. It worked. Great. I now have a formula that will work for any term number I want. It would be no problem to find the 1,000th term, the 1,000,000th term. Who cares? You just plug it in here. But what are we trying to find? We're trying to find the 100th term, right? Right here it says the 100th. So why don't we just plug 100 in right here? We have t equals -3 times 100 plus 10. So t equals -3 times 100, -300 plus 10. T equals 10 more than -300 is -290. That's going to make sense that it's a really big negative, because look, we're already at -11 and we're going down, 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 down. So we're going to end up way down at -290. All right, I hope these are starting to make sense. It's all just variations of a theme now. Now this is kind of weird. They actually call the first term the zero term, but it doesn't really make a difference. It'll still work. The 0 term is 4, the first term is 6, the second term is 8, the third term is 10, the fourth term is 12. You can actually start anywhere. It doesn't have to be at 1, 2, 3, 4. As long as it's a pattern, it'll work. So what's the first thing we should do? We should look at our t's and see what the difference is. Well, that goes up by 2. and that goes up by 2, and that goes up by 2, and that goes up by 2. So we know it's a linear relation. We'll talk about linear relations later, but we know it's a pattern because it's going up by the same amount every time. We're repeatedly adding 2. Well, wait a minute. Repeatedly adding 2 is the same as multiplying by 2. So I'm going to put 2. Now be careful. I know these are all the t numbers, and people often put 2t here. But no, it's 2n. 2n. T equals 2n, and then I'm either going to add or subtract something. Probably. Sometimes it'll work out perfectly, but not always. All right, let's try this first one. If we want to get this number here. So I'm actually going to plug 0 into the n, right? This is the n number. I'm going to plug 0 into the n. 2 times 0 is 0. But I don't want to have 0. I want to have 4. So what do I still need to do if I'm at 0 I want to get 4? I better add 4. Okay, there's my formula. Maybe. Let's see if it works. Let's try this one now. So this is our first term. So we're going to put 1 into this right here, this n. So we'd have 2 times 1, which is 2, plus 4 is 6. Yep, it worked. Let's try this one. We put 2 into the n. 2 times 2 is 4, plus 4 is 8. Yep, it worked. Let's try this one. 2 times 3 is 6, plus 4 is 10. Yep, it worked. Whoops, I highlighted the wrong one, I guess. And let's try this one. Put 4 in here. 2 times 4 is 8, plus 4 is 12. We did it. We found a formula that will relates t to n, and now I could figure this out for anything. If they asked, when n equals 30, so in this upper column, if it asked, when n equals 30, what does t equal? Easy. 2 times 30 is 60, plus 4 is 64. Simple. Okay, one last question. It says determine the number of sides needed to produce 10 polygons. So here you have 1 polygon, you have 2 polygons here, 3 polygons here. Polygons are just closed shapes, right? They only have straight lines. Anyway, don't worry about that so much. So if you look at the number of sides, how many sides is there here? There are 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is 8. So I'm actually going to set one of my tables the n and t table. Let's do that. When n is 1, in other words, the first shape, this is my second shape, and this is my third shape. So 1, 2, 3. This is what I'm interested in. And then I'm interested in 10 after that. Okay, that's what the question is, what goes there. Okay, so when I have my shape number 1, I counted 1, 2, 3, 4, 5, 6, 7, 8, right? So that goes 8. When there's 2, count with me here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's not 8 plus 8 is 16 because they have a shared side here, so it's actually only 15. Okay, now you probably can figure out what number goes here next, but I'll actually count it all out for you. When there's 3 of them, or the third shape, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we get 22 here. Guess what we're going to do now? Find the equation. How are we going to do that? We're going to look at our t values and figure out what the difference is, what's happening every time. Seems to be going up by 7 and up by 7. So we're going to trust that that continues. That's repeatedly adding 7. Repeatedly adding is the same as multiplying. So what am I going to put? I'm going to put 7 and then what letter right here? I'm really hoping you put n. I know this is in the t, but this form is going to help us get the t. It's going to help us figure out the t. So t equals 7n. Now, did that work? Let's see. If I try this one. 1, if I put 1 in there, I get 7 times 1 is 7, but I want to get 8. So what do I still have to do? To get from 7 to 8, you got to add 1. Let's see if it works. Let's try this one. If I put 2 in here, I get 7 times 2 is 14, plus 1 is 15. It worked. Put 3 in here. 7 times 3 is 21, plus 1, 22. It worked. So how am I going to do this? Simple. Now they have the formula. It's no problem, right? I'm going to take this 10 right here, and I'm going to put it in right there. So I get t equals 7 times 10 plus 1. T equals 7 times 10 is 70 plus 1. T equals 71. There's our answer. If we wanted to put 10 of these shapes stuck together, 10 in a row, it would take 71 different sides or edges in order to draw that. Okay, thus endeth the video, and I will see you next time for another video, at which time we will be talking about modeling real-life situations. to you then. Bye.